Beneath the Waves, why NASA is exploring Earth's deepest oceans to unlock the secrets of alien life. NASA has always been synonymous with outer space, rockets, rovers, and distant planets. But what if the key to discovering alien life doesn't lie above us, but below, at the bottom of Earth's own oceans? In recent years, NASA has quietly turned its attention toward Earth's most mysterious and hostile environment, the Hadal zones, the deepest, darkest trenches of the ocean floor. These crushingly cold and pitch-black places are not just geological curiosities. They are potential windows into other worlds, like Jupiter's moon Europa or Saturn's Titan, both of which have vast oceans hidden beneath their icy crusts. But to explore those alien oceans, NASA must first master the one we have right here. From pressure-proof probes and underwater habitats to robotic submarines inspired by deep-sea creatures, the space agency is diving deep. Literally, what are they looking for? What have they already found? And how does a mission to the bottom of the sea help prepare us to explore the cosmic frontier? This isn't just science fiction. This is a radical shift in how we explore the universe. 1. Why NASA cares about the deep ocean. At first glance, it seems strange. NASA, America's space agency, sending its scientists into Earth's oceans, but the logic is compelling. The bottom of the ocean is cold, dark, high pressure, and almost completely unknown, just like many of the icy moons that NASA hopes to explore in the coming decades. Think of Titan, Europa, or even Enceladus. Each harbors subsurface oceans with no sunlight, strange chemistry, and crushing conditions. By studying the Hadal depths, NASA can simulate the exact conditions of these alien oceans without ever leaving Earth. It's far more affordable, more accessible, and more immediate. Moreover, the discoveries at these depths are staggering. Entire ecosystems thrive in total darkness using chemosynthesis, converting chemicals from Earth's crust into energy with no need for sunlight. This mirrors what we expect in alien oceans, making deep-sea exploration not only Earth science, but astrobiology. 2. From the moon to the Mariana Trench, NASA's interest in the deep sea isn't new. In the 1960s, at the height of the space race, it collaborated with the U.S. Navy on Project Sealab, an underwater habitat that tested whether humans could survive in deep-sea environments for weeks at a time. These early experiments laid the foundation for long-duration space missions. Just like astronauts in space, aquanauts faced isolation, confinement, equipment failures, and life support dependency. Today, NASA continues that tradition with programs like NEEMO, NASA Extreme Environment Mission Operations. Based out of the Aquarius Reef Base, an underwater lab off the coast of Florida, astronauts train in neutral buoyancy to simulate weightlessness. They practice spacewalks, test equipment, and deal with the same physical and mental challenges they'll face in orbit. By exploring the bottom of the ocean, NASA isn't just training astronauts. It's building blueprints for survival on distant moons. 3. Challenger Deep, Earth's final frontier. The Mariana Trench in the Western Pacific is the deepest known part of Earth's oceans, plunging over 36,000 feet below sea level. Few have ever reached its lowest point, Challenger Deep. The pressure is over 1,000 times that of the surface. Temperatures hover near freezing. Light cannot reach. And yet, life exists there. In 1960, U.S. Navy Lieutenant Don Walsh and Swiss engineer Jacques Piccard were the first to descend in the Trieste submersible. Then in 2012, filmmaker James Cameron made a solo descent, capturing high-resolution footage and samples from this extreme world. NASA uses these missions as analogs for deep space. In fact, the design of robotic probes for the trench often mirrors those built for Mars or Europa, using similar pressure-tolerant materials and autonomous controls. The Orpheus project, NASA's deepest robot. Yet to reach even further, NASA partnered with the Woods Hole Oceanographic Institution to create Orpheus, an autonomous robot capable of diving into the Hadal zone. It's equipped with AI navigation, adaptive sensors, and a crush-resistant design, all features necessary for future probes to explore icy moons. The first version of its predecessor, Nereus, was lost due to implosion under extreme pressure, highlighting just how hostile Earth's oceans truly are. That failure taught engineers crucial lessons now being applied to Orpheus, and by extension, to extraterrestrial oceanic probes. With Orpheus, NASA is rehearsing not just for the sea, but for the stars. alien life beneath Earth's crust. In 2024, a NASA-assisted probe drilled into the volcanic crust of the Pacific seafloor and found something astonishing: an entire ecosystem hidden inside the Earth itself. Near hydrothermal vents, scientists discovered worms, bacteria, and strange crustaceans living in boiling, high-pressure, zero-light environments. These life forms, known as extremophiles, exist entirely independent of sunlight, thriving on chemical reactions alone. And they may be the exact model for how life could survive on Europa or Titan. Some of these organisms have no eyes, no pigments, and reproduce in total darkness. In essence, they are Earth's aliens, and they're reshaping how we define what life even is. They don't rely on surface conditions, only raw chemistry and resilience, meaning alien life may not need Earth-like environments at all. These discoveries radically widen our scope for where life might emerge across the galaxy. Marine mysteries, creatures from a sci-fi movie. From the vampire squid to the goblin shark, the deep ocean holds creatures so strange they resemble fantasy. Some are evolutionary holdouts, living fossils, unchanged for millions of years. Take the Yeti crab, which farms bacteria on its hairy claws to feed itself, or the mantis shrimp, whose punch can break glass and create temperatures hotter than the sun. These bizarre adaptations show how life adapts to extremes, something we must consider when designing missions to detect or interact with alien ecosystems. Extreme environments breed extreme biology. Understanding how Earth's strangest animals function helps NASA design detection systems for biochemistry that might not look anything like ours, but still thrive in alien oceans. Because if creatures like these evolved on Earth, who's to say what could emerge elsewhere? 7. The Titan and Europa connection. Both Europa and Titan, moons of Jupiter and Saturn respectively, are believed to hold vast subsurface oceans. Missions like Europa Clipper and Dragonfly will explore them soon, but we don't yet know what their oceans contain. They may have geothermal vents, they may have organic chemistry, they may have life. To explore them safely, we must understand how probes behave under pressure, how to recognize biosignatures, and how to avoid contamination. Experiments in Earth's deep ocean give scientists real-time analog environments, proxies to refine instruments, rehearse sample collection, and prepare protocols that protect both alien ecosystems and the integrity of human data. That's why NASA tests these systems here. First, in the deep ocean, where similar conditions already exist. Mapping the unknown. Only 5% explored. It's easy to forget. More than 95% of Earth's oceans remain unexplored. Despite satellites, sonar, and submersibles, the deep sea is still the largest unexplored habitat on the planet. That means we're launching missions to other worlds while still in the dark about what's happening in our own. The next great leap in planetary science may not start on a launch pad, but at the bottom of an ocean trench. Exploring Earth's ocean teaches us how to explore alien ones, reminds us of our limits, and challenges our assumptions about life. New sonar mapping, deep diving drones, and underwater labs now allow researchers to chart unknown seafloor regions, creating the same kind of terrain modeling we'll need for icy moons, comet cores, or ancient Martian lakes. The deep sea is not the end. It's the beginning. When NASA dives into Earth's oceans, it's not a distraction from space. It's a preparation for it. Every robotic arm tested underwater, every pressurized vessel that survives the trench, every life form discovered in darkness, they all bring us one step closer to answering the oldest question we've ever asked. Are we alone? So the next time you hear about a strange fish discovered in the Pacific or a robot diving into an ocean trench, remember, it might not just be an Earth story. It could be the first chapter of an interstellar one. And if you found this fascinating, comment and subscribe, because the more we understand Earth's deepest mysteries, the closer we get to solving the universe's biggest ones.